All right, so I'm here at my friend Patrick's house. Hi, Patrick.
Hey guys.
And Patrick is going to turn this Tesla battery pack from a Model S or X, unknown at the moment. It's, well, we'll get to that, into a what? What are you turning electrified? So I see there's a chassis right there, right? That's a chassis.
It's a frame.
A frame. And then that's a
Tub.
That's a tub of a Jeep Wrangler.
Jeep CJ7, 1984 Jeep CJ7.
Jeep CJ7, which is about to be electrified. And is there a motor?
There is. The motor is over there.
Okay, and what's the situation with the motor when you say over there?
That is the original ICE motor underneath the plastic over there,
next
to the electric lawnmower.
Yeah, I saw those. Those are cool, electric lawnmowers. But is there a motor going in the Jeep?
Yep.
And where's that?
It's right here. We went with the Netgear.
Look at that.
It's an induction motor.
Okay.
It's a 3-phase AC motor.
All right.
Made by Netgear. It's an incredible motor, unbelievable torque.
And how many horsepower is that thing going to be putting out?
I believe the horsepower is about 120 horsepower, but I'll have to check the spec on it.
There's an awful lot of wood on the frame of this car. I'm assuming you know that they don't make cars out of wood anymore, right?
So I decided to because I have to actually build a frame, and I have to put the batteries in here, and I have to build, instead of the motor. The idea was if I used a firewall to represent the tub firewall, I could get my placement down and put my fenders and grill on and off very easily without having to move the entire tub back and forth. Plus, it allowed me to strip out the rest of it because I have to have 2 battery sections. The front will have 4 batteries, 2 over 2. And the back will have 3 batteries stacked where the gas tank would be, which would be right here.
7 modules.
7
and the
total
modules are also coming out of a Tesla?
The batteries are all out of a Tesla.
Okay.
There's 6 of them down below.
There we go. 6, that's what a Tesla battery module looks like when it's not in a Tesla anymore.
This is the actual module here.
Okay.
And this is the actual battery. So there's 444 of these inside here.
Okay.
And this is just an early version of how the series of batteries is going to go.
And do you know where these batteries came from?
They came from a 2018 Model S 18,000-mile Tesla that had been in a wreck, and I got the batteries as a unit. You have to buy the batteries as a unit because once they balance the batteries, they balance them together. So to get a battery from one group to another group makes it very difficult, and they never really balance. So almost all the experts, especially the EV West people and et cetera, they advise you to make sure all the batteries are the same.
All right, and so, but there's more than 7 battery packs in an S, right?
Correct, 14 usually. Right. But the limiter for that motor is how many batteries you can have. So each one of these produces about 22.8 volts.
Okay.
See, if you take all 7 of these and add it together, you end up with 144 volt-ish.
Okay.
That motor is rated at 144 volts. So even if I had more batteries, I would have to do more things with it, but that's about all the volts I can get out of it.
Okay, and what kind of range are you expecting at the end of the day here? Or do you even have an expectation?
Yeah, I do. It's right at 90 miles for the 7.
Okay.
There's theoretical numbers work out to be that way, and because the Jeep is rather boxy, you're not going to get any aerodynamic. But one of the big advantages...
Absolutely none.
But wait. One of the big advantages of the AC induction motor is you can do regen.
Okay.
So anytime I'm stopping, I'm going to be using regen to actually charge my battery. So
stopping
that adds...
in what? What does that mean, though?
Any
regen... You mean the brake regenning?
That's correct.
Okay.
So I should be able to get a theoretical 18 additional miles from the regen. And that just basically makes this about 100-mile...
18 miles during an entire 90 miles, et cetera, of driving.
And that
but
doesn't
you're also
include
probably not going to get 90 miles of range anyways, because I don't get
the
full amount of miles.
I was just about to say,
I drive like a lunatic mostly.
You only get about that 20%, the lower end, you don't ever want to tap into because it makes it harder to bring it back up.
Yeah.
That's right. That's exactly right.
And so what else are we? So it's not going to be 4-wheel drive anymore.
No, that's exactly incorrect.
It's not.
So one of the difficult parts about doing a conversion for this is versus a Volkswagen Bug, you're only trying to drive those 2 wheels in the back of your Bug.
Okay.
If you want to have 4-wheel drive, this, to break it down, is the bell housing, the transmission, and the transfer case. The transfer case job is to allow the power to go straight out to the back. But if you look over here, there's another shaft that brings the power to the front wheels, and that's how you have 4-wheel drive.
Okay.
Now, the only way to make this work is you have to leave a lot of the equipment in the original Jeep intact. So most people would get rid of almost all this, and they just put one thing here to allow the back wheels to drive. But if you want 4-wheel drive, you actually have to go through the transfer case to transfer the motor power to the front.
And you do want 4-wheel drive?
Absolutely. My goal is to have a drop-in, plug-and-play version that you only take out everything from the firewall forward and the gas tank, drop in an assembly that equals your motor, add a platform on top, put your 2 sets of batteries in, and you should be able to drive.
So you're going to tie it into this transmission?
We're going to tie it in directly to the transmission. So the adapter plate goes here. It will connect up to a clutch.
And that motor is going to spin that. So I noticed that this has gear shifts on it. It's going to be like
absolutely
manual transmission.
It is a manual transmission, which is very doable. But unlike ICE engines, you don't really need to match the RPMs to the output.
Okay.
So you only need 2 gears, second and third gear.
Okay.
You don't even need to have a clutch. But the clutch in this scenario acts as a safety. Because you're at 100% torque at 1 RPM in all electric motors, you can't have that much power getting shocked back to your differentials.
Okay.
So you use the clutch scenario to give you that little bit of absorption. So this is the pressure plate for a standard clutch, and this will sit inside here, and that gives you the absorption to not have it rip out your differential every time you come to a hard stop or a hard stop.
Okay.
That also gives you safety because you can always put the clutch in if something goes awry in the electrical.
Right. Okay. All right. So what else? What are more interesting? So this is not like a kit you purchased. This is a thing you're sort of mad scientisting yourself. Is
yeah,
that sort of what's going
I
on?
would love to say that I could buy all the parts, but there are no all the parts. You literally have to do 100% of it yourself. And where I've just stopped at recently, just because I'm busy, is the adapter plate. So adapting the motor to the bell housing is very complicated. You have to have a plate, but you also have to have the coupler.
Okay.
So what the coupler does is it sits on the motor here, and this attaches to, stay there,
Not going
this
anywhere.
attaches to the flywheel, and if you notice, I have an aluminum flywheel here without teeth. I call it a bald flywheel. So I went with ram clutches, had to make this without teeth on it because there's no starter. You don't need a starter for the teeth to engage.
Okay.
So the coupler is the thing that would sit between the motor and the transmission to allow you to have the ability to have the electric motor connect to all the mechanical stuff of the existing product. But you got to make this yourself. So that's what we're working on as well. We're working with a couple different companies, but you have to make this yourself. And this is a big deal.
And how are you going to charge this thing?
We're going to use...
I noticed you have a table of electronics.
So the first step I did was I put all of this together on this table and made sure the electronics works. This is the motor inverter right here.
Okay.
This is the 3 phases that go to the motor, 1, 2, and 3. This is the plus and minus that go to the batteries. This is the actual controller that allows you to accelerate and reverse and do everything. It controls the charging, it controls everything.
Okay.
That comes with the motor when you buy it.
All right.
This is the charger right here. This is a 6.6 kilowatt charger.
Okay.
I went with a fan-controlled or a fan-cooled one.
And what's that a charger out of?
It's
Like,
not.
is it
These
a
are all
car
brand
charger?
Nope, these are all brand new. These are 100% designed just for the aftermarket
For these conversions.
EV conversions.
Okay.
Yes.
And so something's going to plug in here, like is this how the...
Correct. So this particular part
Okay.
connects into here,
Okay.
and that would go to, or could go to, either a juice box of some sort or directly to...
But it's not going to have like a J1772
It
attacher?
absolutely is.
It
Yeah,
will?
we have. Yeah,
Okay.
it has that. And it'll
You're
replace.
You're going to plug that into there?
The only reason I have this plug on here is because for bench testing,
Right.
it was easier just to run a
Okay.
220 line to be able
Copy
to run it on the thing.
Sense. Okay.
This is the DC to DC.
And wait, hold on 1 second. How fast do you think it's going to take to charge it? Let's say you're at 20 miles left and you want to charge it to 90. How long do you think that's going to take? Do you have an idea?
This charger is the larger of the two chargers they make for this.
Uh-huh.
I decided to try to get the larger of the two.
Okay.
You could go with the 3 kilowatt, but at 6.6 kilowatt at the fastest charging, I can get this charged in about 4 hours from almost dead to, which is 20%,
Okay.
to fully charged. Or if I'm at regular 120, I could do it overnight. So 4
like
hours, 5
15
hours.
or so miles per hour. Or
About
something
that,
like
yeah.
that. Okay.
And that's without having too much cooling problems or
All right.
any of those issues.
What's the rest of this stuff going to be used
This
for?
is the DC to DC.
Okay.
What this allows you to do is take the electricity from your batteries and charge your 12-volt battery, which you still have to have to run your radio and the turn signals.
And that's what that Optima is going to be used for?
Correct. I got a
12-volt.
dry cell Optima
Yeah.
to make sure that happens.
Okay.
And
It's a lot of wires, man.
crazy amount of wires.
Crazy.
This is the Orion 2
Oh, the Orion
BMS.
2. Very well known.
It is very well known. This is the #1 BMS out there. So
course.
this allows me...
What's a BMS? What does that stand for?
Battery management system.
Oh,
From your cell
course,
phone
that's what it
to
means.
your calculator to every single car in the
Dude,
world.
that thing's never going to fit in my cell phone, first off. That's ridiculous.
You have to manage how you charge. And you
Okay.
have to have all your batteries
All right.
charged and balanced.
All
And
right, that's fair.
this does all of that.
All right, good.
This is some of the wiring.
Okay, and none of this is
This
out
is
of,
all the-
this
this is
isn't out of an EV. This is just wiring that you had made?
No,
or
I had to
somebody-
make this.
you
Every
made
one
it?
of you make every one of these. So you get the
You use giant knitting needles and that sort of thing to make this stuff?
I wish you spend hours with little diagrams. So each one of these plugs into one of the battery connectors right
Okay.
here.
All right.
So
And those are the original connectors, or that's the EV West additional board that you had to buy to replace?
Correct.
You showed it to me.
So this is it.
Where is it? Oh, it's right here. So here's the original Tesla board. Thank you, Tesla.
right, so this is a onboard BMS that comes with the Tesla batteries.
Okay. And that's in each one of the modules.
Each
has
one of the
those.
modules, correct.
Okay.
So I can't really use this because
want
it
it.
doesn't connect to a Tesla.
Yeah.
So several vendors, including EV West, make one that's a replacement
All right.
that is right there.
There it is. Yeah.
And-
chip shortage there.
And there's no chips on it. It's actually just a pass-through because
Okay.
that thing I showed you over there that won't fit in your phone,
Uh-huh.
it handles all of the BMS.
All right.
And these cables have
Okay.
two separate parts to them. One is for the information that comes out of there, and then the other is to connect to the different
All right.
BMSs. That's what that is.
Is this thing going to have autopilot?
It's not going to have autopilot. You might even have to have a co-pilot.
Yeah. All right.
And then this is all of the connector pieces. So
All right.
each one of these is a module. So for this one is the ignition circuit.
Okay.
And then it was just easier for me to label all these.
All right.
These
there
are all
like-
the ancillary connector parts. So for example, power steering,
Right.
things of that nature.
Are there gauges and such?
Well, you don't really need a whole lot of gauges. So we're going to probably make our own dash. And you're only going to need really to know about the charging state and RPMs
How about how fast you're going?
and a speedometer.
Okay.
Yeah, which in a Jeep, you're not going very fast anyway.
How long do you think this whole project's going to take you by the time you're done, start to finish? I know you've been working on this thought process for a really long time now, and we're going to follow you a little bit. We're going to keep coming back and bugging the crap out of you. But how long do you think it's going to take?
Not long. Now that I have the Tesla case, we can go back and look at that in a minute.
Yeah, I want to see that.
I'll start to chop that thing up into parts to give me my first front and rear battery enclosure.
Okay.
That way I have the exact dimensions for each of the batteries, and I won't have to make it out of something else on the first try.
All right. So you're going to take that green case that we looked at originally with the lid on it over there, and you're going to cut it up into pieces that will hold 2 modules and then 2 other modules, and they're going to
2 on 2.
stack that together.
Correct. 2 on 2 for
Okay.
the front, and then 3 stacked on top of each other for the back where the gas tank went.
And you're using that Tesla battery enclosure because instead of just like, because it's already fabricated, like why is it that you're using that?
Only exclusively for the prototype because it already has 100% of the dimensions for the battery.
So you're just using it as like a template?
I'm using it as a chopped up prototype. So I'll chop up the pieces, I'll assemble it, and then I'll literally take it apart when I get it to the right size, take it to a manufacturer, and they'll make one that's made just for this.
Okay.
But it already has all the dimensions, so it's easier to get that from somebody that stripped a Tesla and sold all the batteries and all the parts. And now I have this product that it literally can take all the batteries in one drop-in section. And if you notice, the batteries fit very specific ways.
I saw that, yeah.
And let me just make a comment real quick.
Sure.
If anybody out there is thinking of doing this, there's a secret no one tells you about.
Okay. This is what we need. This is the magic right here.
You can't orient the batteries
Okay.
in any other direction than this way. So if the front of the vehicle's here, you got to orient the batteries this way. Teslas don't have any compacting or protection in either of these directions.
Okay.
This is the cooling side. This is the electrical side. This is the hot. This is the negative.
Okay.
So if you had to stop quickly, this is going to try to slam into something, and it will destroy all the electrical connections with this. Plus, your batteries will literally slide or try to slide in this direction.
All right.
So Teslas have to, and if you notice the case is this way too, they have to be oriented like this. So don't think to yourself, oh, I'll just get this battery and I could slip one here and I could put one this way. And they don't work like that.
All right.
And they have to be supported. They can't just sit on something.
Okay.
They have to be supported.
All right.
That was a big deal because it changes the design of how you're going to put these batteries in.
So 2 months from now, 3 months from now, we're going to be driving this thing? 5 months?
Well, there's a couple benchmarks. The first one was to hook up all your electric and get it to work and charge.
And it works.
And it works and
charge.
charge.
And you charged it.
Yep.
Beautiful.
Taking all that apart, the next big benchmark is to actually put the batteries in, jack up the car, and let the wheels spin on you hand maneuvering your throttle.
Okay.
So I would literally...
Are you getting rid of this wood? The wood's just a template for metal later?
The wood is literally only for bolting on and
Just temporary.
And testing.
Okay.
Yeah. Because otherwise I'd have to move that tub back and forth.
That's craziness.
So this is my bench test for the throttle,
Okay.
master kill, and the various separations of power.
You're like Doc Brown a little bit. I'm not going to lie.
All right. This is there's 2 different
Am
types.
I not allowed to call you Doc Brown?
I'd rather you didn't.
That wasn't an insult.
I don't like it.
I'm sorry.
So this is one of the
apologize.
other big things. This is your high voltage junction box.
All right.
It is where the electricity comes in. This is your 400 volt fuse.
Okay.
This is your contactor. Which
Is this going in the car?
Yeah. Well, it'll probably end up being steel, but I had to start somewhere.
But all these pieces are
you have
going to
no
go
choice.
in the car.
This is how even the
right.
Teslas work from the same direction.
All right.
So you have the battery has to come in somewhere, and it has to go out somewhere. So this is how it goes to the inverter, which I showed you over there. And this is how it comes from the series of batteries that are going to be distributed in the car.
All right. Well, dude, this thing looks amazing. Can I ask you how much you paid for the battery modules? You don't have to answer, but I'm going to ask you.
I don't
anyway.
mind. And I probably paid a little lower than is actually out there, and I've monitored it for about 6 to 10 months. I paid right at $900, mostly because I was able to pick it up.
For each one?
$900 per module.
So 900 times 7.
Yeah, about an $8,000.
What do you estimate the whole thing's going to run you when you're done?
About 14 to 18 is my guess.
I'm super excited for this, and we're going to come back and we're going to see progress on it.
I can't wait.
Let's go look at the case right before we go, because I'm curious about. That's why I came here, because you told me you got this thing.
Eric, will you help me lift this off?
And so we're gonna.
Eric, if you lift that end, it kind of gets a little folded.
That's Eric, everybody. Say
and we're
hi,
going to go
Eric.
and put this on that thing over there, Eric.
Gonna lift that up. So that's the cover. It's heavier and also very unwieldy looking. This is, if you're driving a Model S or maybe a Model X, this is what the bottom of it looks like.
So one of the things I did, and I'm really into, is mocking up parts. This is an an actual mock-up of the battery itself dimensionally.
Those
batteries,
plastic cases that we saw over there that are holding all those batteries.
Right.
Okay.
This is designed to be exactly the right size. Water cooling on this side, positive and negative on this side.
All right.
This will sit just like this in here, and that's where all the slots will come in.
Okay.
So what I'm going to end up doing is I'm going to end up cutting these two and those two, stacking them on top of each other. That will sit in the front.
Okay.
And then I'm going to take any three of these, stack them one on top of each other, and that will be the trunk one.
Okay, so they're going to get stacked on top. And then are you going to use this lid over here as well?
Well, if you take a quick peek, you'll notice they did a sandwich.
Genuine Tesla part, yeah.
You'll notice they did a sandwich job. So you see these? They sit on top of here.
Okay, these little ridges.
Correct, I'll show you.
that we're looking at.
Let me show you how. They sit like this.
And they hold the battery down?
And they hold the battery down.
Very smart.
So remember I showed you the front versus back?
Uh-huh.
This way the battery can only go this way and that way, not left to right.
Copy that.
That keeps it from ever exploding in one direction or the other.
Unless somebody T-bones you from the side, I
Correct,
guess, right?
but that's not going to...
Then it's over
right,
at that point,
exactly.
so it like, doesn't matter.
So I'm going to probably take that apart just to get the hardware. And if you notice, it already fits pretty close.
Yeah.
So they also came with this.
Yeah, I saw
These are
those.
Little
are kinda
pads, and I believe, I just got this today, I believe it sits like this, and that sits on top of this to just give a gentle push.
These are like dampers, not like thermal transfer
I don't
or anything,
know.
right?
No, I doubt it. I doubt that.
So hey, if you're out there and you know what those things are supposed to be doing, let us know.
It's kind of alumini. I don't know what it is.
In the comments below.
And that's what I just got today, so I'm really excited about that.
Awesome. So I can't wait to see it cut up in the prototyping next time.
Yeah.
I'm going to tell you this. Stay away from my Tesla. There's no parts on there that you can use. None of that's happening. All right, thanks, Patrick. Appreciate it.
See you later.